one of the ways we do research in psychology is through evaluations of correlations. Now, correlational research is about the relationship between variables. And you might raise a question, why and when would we want to do correlational research? If we want to know the relationship, why don't we just go do an experiment? And it turns out that there's sometimes you can't control certain independent variables. If an experiment is manipulating an independent variable and seeing the results on a dependent variable, there are some cases in which we can't control independent variables. So if your question is what's the effects of a person's height on job satisfaction, which sounds like a silly experiment, it probably is. We can't control a person's height. So there's really not an experiment that you can do there. And then sometimes you're just interested in the relationship between variables. What's the relationship between police and crime, for example? If you're interested in the relationship and not necessarily making other conclusions and drawing inferences from that, then maybe correlational research is what you're looking at. So for example, if we were interested in the relationship between the police and crimes, we might do a correlational study. In this case, what I have is I have a table where I surveyed the mayors of certain cities: Austin, Beloit, Cincinnati, Detroit, Eau Claire, Fresno, and Green Bay, and I asked them, how many police do you have, and how many crimes did you have in the last year? And if you look at this, you might say, boy, that's just a bunch of numbers. I mean, there's some low numbers, there's some high numbers, and whatever. Now, typically in correlational research, we plot the data in a particular way called a scatter plot, and that is we use one of these values as an x value, and one of these values as a y value. So Austin gets plotted. The 0.4063762 gets plotted on a graph, and we plot all the points and we see whether there's any relationship. And if we do that, what we see is that the points seem to sort of line up. You can see this is Detroit out over here. It has a large number of police, but also a large number of crimes. But these this looks like maybe Fresno has a fairly high number of police, but also a large number of crimes, so on and so forth. So we look at these, and if they seem to line up, we say that there's a linear relationship. All right, linear, if you want to pronounce it that way, if that helps you mnemonically, remembering what it is, that these things tend to line up. Now, a correlation, technically speaking, is a measure of the strength of this linear relationship. Okay, so we use correlation because we can quantify the relationship. Okay, and typically speaking, in most cases, we use something called R, which really stands for the Pearson product moment correlation coefficient, or sometimes it's referred to as Pearson's R, or simply R. And R gives us the degree, measures the relationship between two things. Now, the nice thing is correlation coefficients only go from -1 to 1, where -1 is a perfect negative correlation, 0 is no correlation, and 1 is a perfect positive correlation. So the degree of relationship is measured from -1 to 1. The strength of the correlation is measured in absolute value. Okay, so strong correlations are close to an absolute value of 1 or -1, whereas 0 is no correlation. That's a weak correlation. Okay, so to illustrate, let me show you a few plots. Right, this is a plot of a perfect negative correlation, and you can see if you drew a line here, you would have, if you remember from algebra, you have a negative slope. This is an example of a perfect positive correlation. As the values in x get larger, the values of y get larger. A negative correlation, as the values in x get larger, the values of y get smaller. So that's the difference between a positive and negative correlation. Now, most things don't line up like this. Sometimes, often in research, we get a relationship like this. And this we would call, so as the values of x get larger, the values of y get smaller, right? Because this is 110 and like 4. So as x gets larger, y gets smaller. This is what we would call a moderate to strong negative correlation. This would be something like a moderate to strong positive correlation. You can see that they line up pretty nicely. This would be a moderate to, generally speaking, as x values get larger, y values get smaller. This would be a moderate to weak negative correlation. This would be a moderate to weak positive correlation. This would be no correlation, where our R value is 0. Now, this value tells us the strength of the correlation, and that's why it's useful. Now, why do we use correlations? Well, we use correlations because when we get good correlations, okay, we can try to make predictions. It can be very helpful in making a prediction. So, for example, if I told you that you had an x value of 0.3, what do you expect the y value to be? You would come up here and say, oh, it's about 0.27. So we can use these graphs, these scatter plots and linear regression to make predictions. So if I told you that I had an observation of x equals 90, you might say, well, yeah, I expect y then to be, I don't know, 35 or so. So that's the value of correlations. Again, the strength of the correlation is measured by the absolute value of the number. Whether it's positive or negative is measured by the negative or positive sign. And that just basically shows you that as one is increasing, the other is decreasing. Hopefully that helps you with correlation. Okay, so we often say in correlation research that correlation does not prove causation. Now, what does that statement mean? Well, it means that does the increase in number of police cause the number of crimes to increase, or does the number of increase in crimes cause the number of police to increase? We know that there's a strong relationship between the number of police and crimes. If we look back at our little figure that I gave you here, that there's a strong positive linear relationship between the number of police and the number of crimes. Now you might say, well, of course, it's got to be that the number of crimes increases the number of police, but could it be that when we have more police out there, maybe they're finding more crime, maybe they're finding more people to speed that are speeding or doing this? Since both of these are feasible, we have what's called the directionality problem. We don't know whether police increase crime or crime increase police. Okay, and that's called the directionality problem. Another alternative to causation is we call the third variable problem. And that is that there's another variable that causes both. So the relationship is a spurious relationship, we call it. Really what's driving the number of police and the number of crimes in a particular city, they don't have anything to do with each other. They're both being driven by population. That is, the higher the population, the greater the number of crimes there are going to be, and the greater number of police you're going to need to police that population. This is called the third variable problem. And this is why we don't think correlation leads to causation. We can have a directionality issue or a third variable problem. And those are the problems with correlation. And hopefully that helps you understand it better.